Now let's start our presentation of the experiment about thermochemistry. There are two parts in this experiment. Part 1, measure the heat capacity of an unknown metal to find out what the metal is. Part 2, measure the heat of a solution and neutralization. Now let me introduce some knowledge we need to use in this experiment. First is the definition of heat. Heat is a form of energy, sometimes called thermal energy, that can be transferred spontaneously from an object at a high temperature to an object at a lower temperature. If the two objects are in contact, after enough time, they will both reach the same temperature. The tools we use is calorimeter. Heat flow can be measured in a device called a calorimeter. A calorimeter is simply a container with insulating walls made so that essentially no heat is exchanged between the contents of the calorimeter and the surroundings external world. Within the calorimeter, chemical reactions may occur or heat may pass from one part of the contents to another, but no heat flows into or out of the calorimeter from or to the surroundings. When we use the calorimeter, it can make sure that the conservation of energy can stand our experiment. Now is the complication and method. There are two main ideas. First, we need to use the equation. The heat equals the specific heat multiply mass multiply delta T, which is the change of the temperature. And because we use the calorimeter and there's no exchange between the system and the external world, we can use the conservation of energy, so that the released heat equals the absorbed heat. Notice that the thermometer reader should be completely under the water, because we want to measure the temperature of the water, not the air. And second, record to 0.1 degree the maximum temperature reached by the water, because when the heat is released, the temperature will raise, and we want the maximum temperature. After the maximum, the temperature will get down, and it will be released, and there's exchange from the system. So if we take the maximum temperature, we can make sure that there's less exchange. Now starts the experiment of part 1. There's the data. Part 1, specific of heat of metal, mass of metal, mass of water in calorimeter, temperature of metal, temperature of water before heated, temperature of water after heated. So when we plug those data in the equation, we can get the change of the temperature, which is the temperature of the water after heated minus the temperature of the water before heated. So according to the conservation of energy, the heat that the water absorbed equals the heat that the metal released. And by this way, we can measure the heat that the metal released, and use the equation to figure out the specific heat of the metal. So through our calculation, we find out the capacity, and we compare the capacity to the chart of the metal's capacity, because every kind of metal have a certain heat capacity, so we can know what the metal is. Because the limitation of the time, I will make a brief introduction of part 2. Method. We will use the same method with part 1. Find the temperature and mass of aqueous before mixing and mixture after mixing, and we can get the change of the temperature and the mass, and we already know the capacity. We consider all the capacity of solution equals to the capacity of water, and then we can calculate the heat. Result from part 2. The acid heat of solution is linear with acid molarity. When we duplicate a certain molarity of solution, we get one result of the acid heat, and we take various acid molarity and get various acid heat, and we collect the data and make a graph so that we can find that the acid heat of solution is linear with acid molarity. Analysis of error. Heat capacity is different because as we consider the heat capacity of solution equals to the heat capacity of water, there's some error because the solution doesn't have the same capacity with water. Second, volume will change after mixing two liquid. We consider the volume be the sum of the two liquid, but actually when we mix it, the volume will be smaller. And the third one is the exchange between the system and the external world, because the calorimeter can't prevent the exchange. There's a little exchange. That's my presentation of experiment. Any questions and cancers at all? Okay, great. Let's move on and proceed then.